Hello everyone. In this video, let's discuss how to write a program to remove duplicates from the sorted list. Given the head of a sorted linked list, delete all nodes that have duplicate numbers, leaving only distinct numbers from the original list. Return the linked list sorted as well. So let's take the example 1. Here we have few elements in the linked list, that is 1, 2, 3, 3, 4, 4 and 5. Here I need to remove the duplicates. So 1 we don't have any duplicate, 2 we don't have any duplicate, 3 we have duplicate, so we have to remove 3 completely. Then 4 also we have duplicate, so we have to remove 4 completely, and 5 we don't have duplicate as it is a distinct element, so the output will be 1, 2 and 5. So 1, 2 and 5 will be the output. Now let's discuss the logic in detail. So here first I have to check whether my head is equal to null, that is linked list is empty. If head is equal to null or head dot next equal to null, which means if I have 0 element in the linked list or if I have only 1 element in the linked list, directly I have to return the head value. Okay, but in that case the condition is false, so I will not go inside the if condition. Now I will start the main logic. So here first I will create a dummy node, list node, dummy is equal to new list node. So I will store the value equal to 0, and in the address part I will store the head value. So here I am going to create one dummy node. I'll give the name of the node to be dummy. Okay. So here I have stored the value 0, and in the address I'll be storing the head. The address of the dummy node I'll consider to be 1500. Along with this, I'm going to take one more object called previous. So here I'll be starting my iteration from the first node onwards, that I'm going to consider to be the current node. So when I'm traversing, I need to know what is the previous node. So I'm going to take one more object called previous. I'll store the dummy. So here this is previous. I'll give the name as previous. Next I'm going to take one more object called current. Current is equal to head. Head is pointing to the node called 2000, so I will be storing the current. Okay. Now I have to start the iteration from the current onwards. So now I have to take a loop. The loop is while current not equal to null. Check the condition whether the current is not equal to null. Yes. If current is not equal to null, I have to check a condition saying that current dot next also should not be equal to null. Yes, current dot next is not equal to null. Along with this, what I have to do is I have to check whether current dot val and the next two nodes val is equal or not equal. Okay, if it is equal, I have to remove that, right? So for that, current dot val equal to current dot next dot val. If it satisfies this condition, I have to go inside the if condition. When I check this, it is not satisfying because current dot val is 1, current dot next dot val is 2. Both are not equal. So I will not go inside the if condition. I will go to the else part. In the else part, what I will be doing is just move previous by one step, which means I have to consider this particular node. So previous equal to previous dot next. So previous is pointing to 1500. Previous dot next is 2000. So now previous will be pointing to the memory location called 2000. So after this if else, I have to go to the next node. I have to continue my iteration, right? So to continue my iteration, current equal to current dot next. That's all. So current equal to current dot next. Current is 2000. Current dot next is 3000. Done. Now go for the next iteration. Check whether current is not equal to null. Yes, current is not equal to null because it is pointing to the memory location called 3000. So go inside, check the condition. Current not equal to null, condition true. So I'll go inside, I'll check the condition that current dot next is not equal to null. Yes, that is 4000, that is not equal to null. And current dot val is 2, current dot next dot val, which is next node address is 4000, dot val is 3. So 2 and 3 both are equal? No. If it is not equal, I'll not go inside the if condition. I'll go to the else part. I'll just move the previous by one step. Okay. After moving the previous by one step, I have to go to the next node. Current equal to current dot next. Okay, current has been moved to next node. Now check the loop. Current not equal to null? Yes, current is not equal to null. If current is not equal to null, what I have to do? I have to go inside the loop. Okay, now check the condition. Current dot next is not equal to null, current dot next is 5000, that is not equal to null. Yes, condition is true. If the condition is true, I have to check the value. Current dot value is 3 and current dot next dot value is also 3. So both are duplicates. If both are duplicates, I have to remove these two nodes. So I will be taking a loop. Why am I taking a loop in the sense? What if I have 3 3s? I have to remove all the 3. For that I have to take a loop. So in the loop, what condition I am going to give is the same condition. Whatever I have given if condition, the same I am going to give, which is current dot next is not equal to null and current dot val equal to current dot next dot val. If it satisfies the condition. Check the loop. Current dot next is not equal to null. Current dot val is 3. Current dot next dot val is also 3. Both are true. If both are true, don't do anything. Just go to the next node. Just move the current to the next node. Current equal to current dot next. So current from here, I'll go to the next node. Now check the loop again. Current dot next not equal to null. Yes, current dot next is not equal to null because we have 6000. Current dot val is 3. Current dot next dot val is 4. Both are equal? No, not equal. So I'll come out of the while loop. After coming out of the while loop, I should not consider this node and I should not consider this node also. So in previous dot next, what should I store in the sense? Wherever current dot next is pointing, that should be stored in previous dot next. Why? Because these two are equal, we have found. Now these two nodes, this node and the next node are not equal, which means the next node is not a duplicate node. As of now, the next node is not a duplicate node. So what I'll be doing is, after coming out of the while loop, in previous dot next, which is previous is pointing to 3000, previous dot next, what I'm going to store is current dot next. Current is pointing to 5000, current dot next is 6000. So here I'll store the value called 6000. Okay, then which means now first I'll be traversing to first node, then I'll go to 2 next node, then I'll go to 6000, which is I'm ignoring these two nodes. I'll go to this node. As of now, I don't know whether it's a duplicate or not. Let's traverse and we'll figure it out. Now current, that's all. If condition got over, I'll not go into the else case. Current equal to current dot next. Current is pointing to 5000, current dot next is 6000. Now current will be pointing to 6000. Check the loop again. Current not equal to null. Yes, current is not equal to null. Go inside. Check the condition. Current dot next is not equal to null. Yes, that is not equal to null, 7000. Current dot val is 4. Current dot next dot val is also 4, which means we have got a duplicate. Okay, if you have got a duplicate, go inside the while loop. Check the condition, that is true. If it is true, what I have to do? Move the current by one step. Now check the loop again. Current dot next is not equal to null. Yes, it is 8000 not equal to null. Current dot val is 4. Current dot next dot val is 5. Check where both are equal. No, it is not equal. If it is not equal, come out of the loop. After coming out of the loop, what I have to do? In the previous dot next, I have to store the current dot next, because current dot next is not a duplicate element, because these two are not equal. So as of now, the next current dot next is not a duplicate element. So I'll store current dot next value, which is 8000, in previous dot next. So 8000 will be stored in previous dot next. Done. Then come out of the if condition, then go for the next node. Current equal to current dot next. Okay. Now go for the loop again. Current not equal to null. Yes, current is not equal to null. Go inside. Current dot next to not equal to null, because this condition is to check whether I've reached the last node or not, because current dot next is equal to null. Whenever I'm saying current dot next is not equal to null, we have not reached the last node. Whenever current dot next is equal to null, it states that we are in the last node. So I'll come out of the if condition. I'll come out of the if condition. What I'll do? Previous equal to previous dot next. So previous will be pointing to this node. So 8000. Now previous has to point to the memory location called 8000. Then go for current equal to current dot next. So from here I'll go to next node. That's all. Now check the loop again. Current not equal to null. Current is equal to null. Come out of the loop. We have reached the end of the linked list. Finally, I have to return something, right? Return dummy dot next. Don't return dummy. When I am returning dummy, it returns the memory location 1500. I am going to return dummy dot next, that is 2000. Okay, when I am returning 2000, this is the first node address. Okay, let's traverse and check whether we are getting only 3 nodes, 1, 2 and 5 or not. So I'm reading 2000. So first node is 2000. I'll take the data value as 1. Okay. Then go to the next memory location 3000. I'll take the data value as 2. I'll go to the next memory location 8000. I'll take the data value as 5. That's all. We have removed the duplicates. This is the logic of the program. Now let's go for the implementation of the program. Okay. So first let's check the base condition. The base condition is if head equal to null or head dot next equal to null. If it satisfies any one of the condition, return the head value. Else go for creating the dummy node. List node dummy equal to new list node 0, head. Now I'll create one more node called previous. This previous equal to, I'll store the dummy. I'm going to take an object called current where I'll be pointing the head node. Take a loop, check the condition current not equal to null. If current is not equal to null, first what I have to do, I have to check a condition saying that current dot next is not equal to null to know whether I have reached the last node or not, and current node value equal to the next node value, current dot next dot val. If both are equal, I have to take a loop. I have to remove the duplicates, right? So I have to take a loop. I have to check the same condition. Current dot next is not equal to null, and current dot val equal to current dot next dot val. If it satisfies the condition, so just move current by one step. Current equal to current dot next. Once the loop got over, I have to update previous dot next is equal to current dot next, because we are removing the duplicates. Else just move previous by one step. Previous equal to previous dot next. Finally I have to go to the next node. So current equal to current dot next. That's all. This is the logic of the program. Finally I have to return dummy dot next. Let's run the code now. Yes, it passes the test cases. Let's submit the code. Yes, it passes all the test cases. That's all.